Hello, we are Team xgboosted and welcome to this demo of Sentinel, our solution developed for the SMU BIA Datathon 2025. Sentinel is designed to analyze unstructured text data, extract meaningful insights, and present them through interactive dashboards and visualizations. This enables security analysts to make informed decisions and enhance intelligence gathering and security analysis. We will first walk you through setting up the Sentinel dashboard on your local machine. Then, we'll showcase its key features in action. Before we continue, the link to the GitHub repository will be provided below with instructions in the README. Please refer to it for more detailed information. Make sure you have installed Python, pip, git, and a web browser before proceeding. First, we want to open PowerShell. Then, we want to change the working directory to where we want our folders to be installed. In this case, I want to install in this demo folder. So I'll run cd, I'll copy over the path, and we can see that the working directory has been changed to this folder. Next, I want to clone the repository using git clone, and I'll copy the repository link over, and with a space and a dot behind. And then all the files has been cloned into this folder. You can see this over here. Next, we'll want to set up the environment. So firstly, we'll run python-m virtual environment. So this will create a virtual environment to be ran on. Next, we'll want to activate the virtual environment. So virtual environment /scripts/activate. You can see now we are in our virtual environment. Next, we'll want to install all the packages, Python packages that will allow the app to run using python-m pip install-r requirements.txt. Now our installation is complete. We'll want to run the app. So we'll do that using python app.py. As you can see, Dash is now running on this local port here. You don't need any internet connection to run this. You'll just want to copy this link and paste it into a web browser. We are now in our dashboard. Before we demonstrate the dashboard, it is important to understand ISD's function to protect Singapore from threats in these areas. Firstly, terrorism and violent extremism, espionage, communalism, and cybersecurity threats. We will abbreviate these as TCCE and they will be mentioned in the visualizations. Now, let's explore our dashboard. The first visualization is a world map. This map displays where TCCE incidents occurred by country. We can hover over the circles to see the exact count of incidents. The legend, number of incidents, indicates the number of incidents per country. We can use this slider to filter by incident count. So if it's at 50, the incident count will only show countries that have more than 50 TCCE incidents. Whereas if we put it at 0, it will display all countries. We can zoom in on a specific part of the map for easier visualization, and we can zoom back out as well. Double-clicking resets the visualization. Lastly, as the data given is filtered either by news excerpt or WikiLeaks articles, we can filter by news or leaks. Our next visualization is a pie and bar chart. The pie chart shows the proportion of different threat categories, while the bar chart displays the exact count for each. We can hover over each section and each bar to see the exact count of incidents. We can also filter by news or by leaks. Next, we have line charts. These line charts track the occurrence of different threats over time. If a count is 0, that means that the incident falls under one of the other three categories. We can hover over the lines to see the exact values. We can also draw a rectangular lasso if we want to focus on a particular period of time. Double-clicking resets the visualization. We can also filter by news and leaks for line chart as well. Our last visualization is a network graph. This visualization shows connections between countries based on shared threat incidents. Clusters may indicate regional ties. Singapore is placed at the top in a tree-like format to ensure easier visualization. We can drag nodes to explore their relationships, and we can also click on particular nodes to find the exact incident IDs for these connections. We can also filter out by various TCCE categories. So for example, if we want to include everything, the size of the graph will become bigger, and if we filter out by categories, depending on each category, the graph will become smaller. With Sentinel, ISD can analyze patterns, track trends, and uncover critical connections to stay ahead of emerging threats. This will be all for the demonstration video. Thank you for watching.